getting toward the end here. Here we go, 9.4, 9.3. I can't even read, I'm so tired, it's so late. Look at that, look at the time. Okay, look at the, never mind. Anyway, 9.3 is logarithms as exponents. We've done this recently, so I'm going to be really quick. If we have y equals log base b of x, it is the same as x equals b to the y power. We call this log form. Log form. Sorry about that. I can't do. Exponential form. Log form, exponential form. As long as b is greater than 0 and it's not equal to 1. Got it? So here's some examples very quickly. So you have log base 8 of 4 equals x. What that means is 8 to the x equals 4. Well, but what is x? We solve it. 2 to the third raised to the x power is the same as 8 to the x. And 4 is the same as 2 to the second power. What do we do when we raise a power to a power? We multiply. So we get 2 to the 3x equals 2 to the second. What does that mean? That means that I'm going crazy and so are you. It means that 3x has to equal 2. In order for this to be true, this must be true. Solve for x, x equals 2/3. There you go. You can solve using logarithms. These are some special things you should remember about logarithms. If we take b and raise it to the log base b of x power, it's going to equal x. If we take log base b of b to the x, it also is equal to x. That's one. Also note that if we have log base 6 of x to the second power, it's the same as 2 log base 6 of x. In other words, an exponent becomes the coefficient of the whole thing. Thus, we have log base 2 of 8, and we don't know what it equals. We want to figure it out. Well, we do know that 2 raised to some power, we'll call it x, has to equal 8. So we can write 2 to the x equals 2 to the third, which means what? It means that x equals 3. Therefore, we can say the value of this is 3. Quickly, one more time. Log base 2 of 8, the value of that is 3 because we do this. Next, also, you need to remember that in this situation, you have log base 3 of xy. It is the same thing as log base 3 of x plus log base 3 of y. Likewise, log base b of x over y is the same thing as log base b of x minus log base b of y. Two more very important things that you need to remember. He's laughing. All right, anyway. Next, 9.5, common logarithms and natural logs. I didn't put up the natural logs up, but the natural log looks like this when you see it on a keyboard. It's a number just like e, which is also part of this, and pi. They just are there. They exist, but we don't try to put an exact number to them. Base, when we talk about base, is a common log, that is, so what, base 10 is the common log. So log 6, we really mean log base 10 of 6. Those are the same thing. Well, how does that work then? Well, if I said log 1000, what I'm really asking is, what power of 10 will give me 1000? And that would be 3, because 10 to the third power is 1000. So the value of this, because it's an imaginary base 10, is 3. We talked about magnitude of earthquakes. Did you feel it? That didn't really happen. I'm not awake right now. Anyway, we talked about magnitude being m equals log base 10 of t. We can use that. If we want to find out, we can also say, therefore, that 10 to the m power equals t. So that if we have log t equals 8.3, what we're saying is that 10 to the 8.3 power equals t. And when we do that, we get a value of 2.00 times 10 to the 8th. What does that mean in terms of this stuff? Let me pull it up maybe so you can see it a little clearer. There it is. It's just above my head. It's over my head. Anyway, what that means is an earthquake with a of magnitude 8.3 is 2 times 10 to the 8th power. The 8th power, that is hundreds of millions times stronger than the least detectable earthquake. In other words, something like around, 1 on the Richter scale. This is 2 times 100 million times stronger than that earthquake. Pretty devastating. Pretty devastating. If it happened right here, right now, this building would come down. Maybe not, but probably pretty close. Be damaged severely, right? All right. Anyway, let's see. Is there any more that I put up here? 9.6 exponential equations, change of base. So if you have a problem like this, 5 to the x power equals 12. You can use log to figure out what the value of x is. So we go log 5x, 5 to the x power equals 12. So what do we do with that? Well, we move it on, and we go log 5 of x up to the x equals log 12. And then we remember that rule about exponents. The exponent becomes the coefficient. So we have log 5, x times log 5 equals log 12. And just like all those other times when you try to solve certain problems like this, we're going to divide both sides by log 5. Now, none of you are in here, including me, is smart enough to know right off the top of your head these values. But we do know that if we come up with these values, x will equal log 12, put it into the calculator, divided by log 5. And that would be the value of this particular, the value of x for this particular situation. I'm looking at the time, trying to get through here really quickly. All right, so here we go. 10.1 is about circles. You need to remember this. This is the standard form, x squared plus y squared equals r squared. That is the equation of a circle with the center at the origin and the radius of r. R is the radius. But the better one, x minus h squared plus y minus k squared equals r squared. That's the better way to represent it, because even if it's at the origin, you put a 0 here and here, it's not really changing anything. So it gives you h, k is the center, the radius is, of course, r. You need to know that in order to graph circles. So if I gave you an equation, you need to be able to graph that equation. And we talked about 4 different ways: linear, quadratic, circles, and ellipses. So if you have this equation, x minus 6 squared plus y plus 2 squared equals 25, you know that the center is 6, -2, and that the radius is 5. So these 4 points are on the circle. 6, -7, 6, 3, 11, -2, and 1, -2. Those are 4 points on the circle because they are all 5 units from the center. And the center again was 6, -2. No, I'm going to use this very quickly. The last thing I'm going to do on this particular segment of the tape is talk about ellipses. This is the standard form right here, standard form of an ellipse. the equation of an ellipse. X squared over a squared plus y squared over b squared equals 1. That's centered on the origin. Therefore, a0 and negative a0, 0b and 0 negative b are on the circle. Likewise, you can write it different. You can write it x minus h squared plus y minus k squared. And this is over a squared and this is over b squared equals 1. What does that give us? It gives us a center, again, it gives us a center of HK. HK. And the vertices will be these 4 items. H plus A, K, H minus A, K, and H, K plus B, and H, K minus B. So those are the 4 points. So you've got the easy one, and you've got one a little more difficult. You need to be able to graph both of those particular things. That's the end of section 10. I may or may not do 11.1 and 11.2 because you just saw those. We can talk about those on June 8th. So you lucked out. This video, I don't know how you're going to see all the videos, but I'm going to try to upload them all onto the desktop. And by the way, bye.